Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick to the end of the video to solve a bonus problem that is similar to this one, and which you guys can try to solve. So I have 2 to the power of x is equal to 3 to the power of x plus 1. I want to find the value of x. So first off, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So now I have 2 to the power of x is equal to 3 to the power of x plus 1. We could rewrite this as 3 to the power of x times 3 to the power of 1. Now, if I divide both sides by 3 to the power of x, I get 2 to the power of x over 3 to the power of x is equal to, and then these two will cancel out, so I'll simply be left with 3 to the power of 1. Now 3 to the power of 1, this is the same thing as simply just 3, so now I have 2 to the power of x over 3 to the power of x is equal to 3. And now if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So in this case, a is equal to 2, m is equal to x, and b is equal to 3. So this would be equal to 2 over 3 to the power of x, which is equal to 3. So now, if I take the log on both sides, I get log 2 over 3 to the power of x is equal to log 3. And now an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would be equal to b times log a. So now in this case, I can move my x here to the front. So this would be equal to x times log 2 over 3 is equal to log 3. And now I'm going to divide both sides by log 2 over 3. So then these two cancel out, and I'm left with x is equal to log 3 over log 2 over 3. So now, if I have something in the form log a over log b, this is equal to log base b of a. So in this case, this means that x is equal to log base 2 over 3 of 3. So we have x squared is equal to 3 to the power of x. Now what I'm first going to do is I'm going to take the natural log, which is ln, on both sides. So now I have ln squared is equal to ln 3 to the power of x. So now, if I have something in the form ln a to the power of b, I can actually move this exponent b to the front of the logarithm. So now I have b times ln a. So ln a to the power of b is equal to b times ln a. And this obviously also works for normal logarithms. So if I have log a to the power of b, I can move the exponent to the front. Now I have b times log a. So now going back to our problem, ln x squared is equal to ln 3 to the power of x. If I use this property, I can actually move both my exponent here to the front. So now I'll have 2 times ln x is equal to x times ln 3. So now what I'm going to do is I'm going to divide both sides by 2x. So then for my left-hand side here, these two 2's will cancel out, so I'll be left with ln x over x. And now this is equal to, for my right-hand side, the two x's will cancel out, so I'll be left with ln 3 over 2. So now, if I have something in the form e to the power of ln a, this is equal to a. And if I have something in the form e to the power of ln x, this is equal to x. This is because e and ln, these two will cancel out. So remember this property. So now what I'm going to do is I'm going to, well, x here, this is the same thing as e to the power of ln x, right? So now I can rewrite x as e to the power of ln x. This is still equal to ln to 3 over 2. And now, if I have something in the form 1 over a, this is equal to a to the power of negative 1. So ln x over e to the power of ln x, I can rewrite this as ln x times 1 over e to the power of ln x, which is equal to ln 3 over 2. And this is equal to ln x times e to the power of negative ln x, which is equal to ln 3 over 2. Now if I take the W-Lambert function of something that is in the form a times e to the power of a, this is simply equal to a. So now I will take the W-Lambert function on both sides. So now I have w of ln x times e to the power of negative ln x is equal to w of ln 3 over 2. And now remember, if I have w of a times e to the power of a, this is equal to a. So actually, before doing this, I'm going to have to multiply both sides by negative 1, because both a's have to be the same. In this case, a is negative ln x. So now this is negative ln 3 over 2, and this is negative ln x. And now, the w of this is simply equal to negative ln x, which is equal to the w of negative ln 3 over 2. Now, if I take the power of e on both sides, I have e to the power of ln x to the power of negative 1, because I can move this to the front. And this is equal to, e to the power of w negative ln 3 over 2. Now remember, e's and ln cancel out, so now I have x to the power of negative 1 is equal to e to the power of w of negative ln 3 over 2. And x to the power of negative 1 is the same thing as 1 over x. So now I have 1 over x is equal to e to the power of w of negative ln 3 over 2. And now I can switch these two out. So now I get x is equal to 1 over e to the power of w of negative ln 3 over 2.